Hello everyone. Today we are going to talk to you about happiness. Our data analysis that we did for a STAT 324 project was on a data set collected that described happiness on a scale of 1 to 10 from countries all around the world. This graph shows you a color heat map of the happiness ratings for different countries. The ratings varied from 1 to 10, with 10 being the most happy and 1 being the least happy. This dataset also contained other values such as family, a variable which accounted for the amount of trust that someone had in their family members, and GDP, which accounted for a given country's GDP. In the third part of our project, we calculated a binary variable using happiness score. This binary variable had the value 0, which represented not happy, and a value 1, which represented happy. We created this. We decided to create the cutoff of the happy and unhappiness portions using the mean of the happiness score. You can see from the box plot and the code run in R that the mean was about 5.45 because we wanted about 50% in each of the binary responses groups. This next slide shows whether or not a country was happy or unhappy by our coded binary variable, and then the mean GDP for those two categories. We see that the happy country the countries that were coded as happy have a significantly higher GDP than the countries that were coded as unhappy. This indicated that GDP would be a good predictor of whether or not the country was coded as a 1 or a 0, happy or unhappy.
And then we also decided to see the distribution of countries that were happy and not happy based on the variable of family. As you can tell here by the summary statistics, the mean for countries that were not happy versus the mean for the countries that were happy are not so much different from each other. If anything, they're only 0.3 points apart from each other. As well as you look at the box plot below, you see that the variability for countries that were happy versus the variability for countries that were not happy differs a lot. For countries that were very happy, the variability is very small, while for countries that were not happy, their variability is almost as double the length of the box plot for countries that were not happy. Now, if we go back and see countries that were happy versus countries that were not happy based on GDP, we see that the variability for both of these different groups is nearly the same. Therefore, because we want the variability to be nearly similar to each other, we decided for our single predictor model to use GDP. And here we can see the regression plot based on GDP, guessing whether a country is happy or not. And when we look at the goodness of fit statistic, we see that we have somewhat of a high deviance for chi-square. In addition, we also see that the probability for this chi-square is 0.90, meaning that there is no evidence for lack of fit. Therefore, we can conclude that using GDP as for our single predictor model is a good prediction to determine if a country is happy or not. Now, if we move on, here's the confusion matrix for the single predictor model, again saying that uses GDP, and here we see that we have 15 false negative, and then we have 9 false positive. With adding these two together and then dividing it by the total number of countries that are in our model, which is 126. To clarify, our model is based on the training data, which has 126. We get a classification rate of 80% or a not classification rate of 20%, meaning that our single predictor model does a good job, basically 80% the time that it predicts is going to do a good job in predicting whether a country is happy or not. Now, if we go to our classification tree, we see that the first split that it does is economy GDP, meaning that this variable is the one that decreases MSE the most. Then the second split that the classification tree does is actually by family, meaning this that the second most variable that decreases MSE the most. Then the model decides to split it by regions. When doing the classification tree, we weren't sure how many splits will be appropriate to do. So then we look at the split history with the cross validation, and here we see that it's recommended for us to do 6 splits to get the highest R-square, which would be 0.72. However, we didn't see it necessarily for us to go all the way to 6. We actually, on our report, we did it all the way to 3, because after 3 splits, the R-square starts to plateau. So we didn't find it significant enough to add more variables when the increase in R-square was not as significant. Therefore, we decided to go for 3 splits for our multiple regression model. That's it for today. Thank you for listening to us. Remember, be happy.